Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Got a great topic for you today. Here it is. Integrating Fotress safety and Horner OCS using ASi. Fotress is a company that manufactures safety interlocks and other similar gear. I've heard a lot of good things about the company and the products, and I'll have to say, from working with it for the past several days, I am impressed. It's very rugged stuff, seems very well designed, and I'm looking forward to showing you how to interface it with Horner controllers. Here we go. Today we're going to get started with a quick introduction to tGard from Fotress. It's a really nice product. Just going to give you a quick introduction. There's lots of information available online or from your local distributor or your local Fotress rep. After we give you a quick introduction to tGard, then we're going to do a one-slide ASi review. Now, ASi is a network we've covered actually quite often on this channel over the past couple of months, so I'm not going to spend too much time on ASi itself. We have other videos you can take a look at that'll give you more details. We're going to take a look at the architecture of what we're setting up today, what the integration steps are, and there'll be plenty of demonstrations throughout. Actually, we're going to spend more of our time on demonstrations than anything else. Okay, so what is tGard? Well, it's a highly configurable family of safety interlock products from Fotress, and it's definitely one of the most popular product lines of its kind, and certainly it's very flexible and very fully featured. I know that we have lots of current customers that are using tGard and other Fotress products. A lot of our distribution channel are really excited about this product, and of course there's other products on the market that compete with tGard, but this is an example of a really nice family of safety interlock products. Okay, so what are some of the features and functions of tGard? Well, it's definitely very durable. When I show you the system I have on my bench today, I think you'll be impressed with just how durable it is. It's, built like a tank, really. Although it's not huge, it's got a very compact footprint. I remember back in my early days as a controls engineer back in, the 80s and 90s, that equipment was quite a bit larger than this. But tGard has a nice compact 40 millimeter by 40 millimeter footprint. Now, from an installation standpoint, it's pretty easy to install. It just has 2 mounting points. Couldn't be simpler, really. And it is so configurable. It has up to 10 modules per unit. The unit I have has the capacity for 8 modules, and I think it has 6 of them installed. So very flexible for sure. Now, what are some of the modules that you can include in a tGard unit? Well, you've got safety switches and personnel keys, an escape release, you've got e-stop buttons, other just standard push buttons and selector switches, operating handles. It even can handle RFID. So again, pretty flexible in terms of the different modules that you can install in a unit. Now, in terms of how you interface with it, certainly you can hardwire to it in a traditional fashion, but it also has the capability of being networked using either ASi or IO-Link, both really good options. Now, today we're going to be showing you how to do it using ASi, but certainly IO-Link is another option. Now, the advantages of connecting tGard using a network like ASi or IO-Link are there's several, but here's a couple of them. It reduces your cabling and installation cost, and it gives you access to a lot more data and certainly a lot more diagnostic data than you would get through hard wiring. Okay, so what does the architecture look like for the system we're going to demonstrate today? Well, there's a Horner controller that's handling the machine control, all right? And then you have a B&W ASi gateway and safety monitor that's managing the ASi network, and it's acting as the controller of the safety logic and the safety outputs, okay? And then the Fotress tGard products are just sitting directly on the ASi network, reporting back to the B&W ASi gateway and safety monitor. And then the Horner controller and the gateway and safety monitor are just exchanging data over Modbus TCP. So really straightforward, couldn't be simpler. Okay, now in terms of where the data resides in the gateway and safety monitor from a Modbus TCP standpoint, well, you've got effectively a bank of Modbus TCP holding registers that contains the ASi input data coming from the field. And then you have another bank of ASi output data going to the field that is residing in a different set of Modbus TCP holding registers. Now, in addition to the standard ASi input and output data, there's also the status for the safety outputs, the OSSDs. And those are available in a different location, a different holding register. There's a bank of, I believe it's 16 holding registers. But if you only have, a few safety outputs to manage, then you're just going to be looking at, a couple, maybe a few more than that, holding registers to get your status of your OSSDs. All right, so the first thing we're going to show you is the tGard unit that I'm working with today, and what it looks like, how it's constructed, all that sort of thing, and how we get it on the ASi network. Okay, let's take a look at the equipment we have here on the bench. Here's the tGard that I'm working with today. This is a highly configurable product, all kinds of different options, all kinds of different configurations. This happens to be the one I have here today. A very rugged piece of gear. Okay, this particular unit that I have has a couple different safety circuits built into it. It's got an e-stop button. It's also got a door switch safety circuit for controlling a gate. Okay, and this particular unit interfaces over ASi. Now, they also have options available for IO-Link, but we're working with ASi today. Now, there's an M12 connector physically on the bottom of the tGard for ASi, and to get that physically on the ASi network, we need to use one of these passive interfaces here from Beal and Wiedemann. So what this device does, let me move the tGard out of the way, is it basically uses the normal ASi vampire technology to create a node vampiring into both the yellow ASi network cable as well as, in this case, the extra flat power cable that some ASi systems use for devices that need more power. And then after clamping on those two particular cables, then it provides, coming out this end here, it provides the M12 cable to plug into the bottom of the tGard in this case. Okay. Now let's take a look at what we have here from an ASi standpoint. So physically, we've talked about how to physically connect it, but in terms of the ASi addresses or ASi functionality we have here, we actually have 4 different ASi addresses built into the tGard. So it has 2 safety circuits, okay? It's got the door switch safety circuit. It's got an e-stop safety circuit. And those are addressed at 0 and 1 on the ASi network by default. And then it has some push buttons and some, status indication that are just standard I/O. And those by default are addresses 2A and 3A. Now, because those addresses don't start with a legal address, they start with 0. Most ASi devices ship from the factory at 0. So we need to move those addresses up to a legal range before we can actually use the tGard on ASi. So we're going to have to use some sort of addressing tool to do that. We could use a handheld programmer, or in my case, I'm going to be using the safety monitor, which has a built-in provision for setting slave addresses. Okay, let's do that now, or I'll show you how that's done. So we're going to move 0, address 0 to 10, address 1 to 11, address 2A to 12A, and address 3A to 13A. Remember, those standard I/O addresses don't take up a full address. That's why they have the A on the end. All right, so let's go ahead and get into the menu system on the safety monitor. I'm going to go down using the down arrow key until I see the slave addressing tool. I'll press OK there. We're dealing with ASi 3 circuit 1. That's where we're physically connected. Okay. And then I'm going to go ahead and press OK on the Connect New Slave option. Now, the old address is set at 0. Okay, so I want to leave that there because I want to change old address 0 to new address 10. Now, to get a 10 here, I need to hit the OK button until I see a 10. Okay, so I did that repeatedly. Then I'm going to arrow down to the program option and hit OK. And it tells me that that went okay. So I've successfully changed address 0 to address 10. And I'm going to follow the same procedure to change 1 to 11, 2A to 12A, and 3A to 13A. I'm going to do that offline though. I think you get the gist of how that's done. Okay, so this is the first step, getting the tGard onto ASi and get it addressed properly. Before we continue on with our demonstrations today, I just wanted to have a couple of slides where I summarized basically the data, if you will, that is available from the tGard, both from an ASi standpoint as well as from an ASi address standpoint, as well as from a Modbus TCP holding register standpoint. So if you're actually, trying to do this integration yourself and using this video as an aid, you can see specifically which ASi nodes and which Modbus TCP holding registers I used in this particular demo. So here, let's take a look at ASi node 10 and 11, which is the safety nodes on ASi and the specific Modbus TCP holding registers where this is accessed from. Okay, so that is the safety addresses, if you will. And then from a general purpose IO data standpoint, which is nodes 12A and 13A on ASi, here are the specific Modbus TCP holding registers for the data you see here on the screen. Again, I just wanted to have this here for those folks who are actually doing this integration and trying to use this video as a guide. Okay, so with that information available for a freeze frame, next let's go ahead and wrap up. We have quite a bit of configuration to do. We're going to take a look at the configuration of the safety monitor using the B&W software. Then we're going to watch or take a look at the system operating at runtime on the bench after everything is fully integrated. And then we'll go back and see the Horner Cscape program that was used to create that demo functionality on the bench. All right, here we go. I fired up the safety monitor software, ASi 360. The next step is I'm going to create a new workspace. Okay, and I'll give it a name. Let's go ahead and call this Fotress tGard. Okay. All right. We'll say I've read the notice here, telling me it's got the default settings. I need to select my safety monitor, which I believe is a 3958. There it is. Okay, so we've got a 3958 selected. All right, here's the information on this particular device. Let me scroll down and hit OK. And OK once more. All right, so here we are with a blank configuration. Let's start adding the tGard. Remember, it takes up 4 addresses, and we've readdressed those starting at 10. So where do we find those? Well, let's go ahead and start by selecting Add ASi Module to Circuit 1. That's what we're dealing with today. And we need to go to the ASi Universal Modules. And number 10 is basically a safety guard. Okay, Universal Safety Module, Safety Guard. So that's the device we want for address 10. All right. And then from the standpoint of the I/O, all the I/O by default is not enabled. We need to enable output 0 in this case. Okay. All right, we'll hit OK. And we've done that. Okay, so now, oh, it put it at address 1. We didn't want it at address 1. Let's go ahead and move that. All right, edit the ASi module. All right, and under address, I needed to change that to address 10. Okay, network 1, address 10. There we go. Now we've got it in the right spot. Okay, so address 10, the first address, is successfully configured. Let's configure to address 11 next. Okay, we're going to add another module back to the Universal Safety Module. This time, we want not a key guard. We want a safety module. We want an eStop. Okay, so let's find eStop. There we go. It's the first one on the list. Okay, we want this to be at address 11. All right, and we'll hit OK. The standard I/O configuration is fine in this case. All right, now we need to get 12A and 13A added. So let's do that. So again, add to circuit 1, back to the universal modules, but this time we're not dealing with safety modules. We're dealing with universal AB module in the case of 12A and 13A. So let's select this guy. Okay, let's get him onto 12A. All right, and then by default, its standard IOs are all disabled. We definitely need these to be enabled, and we're going to enable all of them. In this case, we are not needing to enable the final output. The first two outputs will enable, but not the third one. Okay, so that's the configuration we have for this guy. And remember, we'll talk about specifically what each of these IOs represents here in a little bit. All right. And then next we need to get 13A added, so we'll do that quickly. All right, add to circuit 1. Again, it's a universal module. It's not a safety module. It's an AB module. We want to get it onto 13A. Okay, and from a standard IO standpoint, in this case, we really only have one input that's going to be coming in through this address. So I'm going to enable that first input. Okay, in this particular case, it's the status of one of the key switches. Okay, got it. So now we've added all 4 of these addresses. Okay, so that looks good. All right, let's hit OK. All right, less than 5 full ASi addresses are used in circuit 1. Do you want to simulate the missing ASi nodes? Yes, remember, I think we've covered this before with ASi. When you have a network that just has a few devices on it, it will automatically add some dummy addresses to keep the timing working perfectly. It does that by adding dummy addresses to the end. So we'll go ahead and say yes here. All right, and then it'll go ahead and add those dummy addresses to the end. All right, and then it basically prompts us to save the file, which we do. All right, and now we can go ahead and configure the safe output that we're going to be using in our demonstration today. Okay, so by default, we have our safe output here, safe output number 1. This particular safety monitor has multiple safe outputs we could work with, but we're just going to be dealing with safety output 1 today. These, we're going to be connect to this and gate here. We're going to be connecting all the devices that are going to be required for the safe output to be active, and then connecting to this particular push button here, we're going to connect whatever we're going to use to effectively restart the safety circuit after it has been tripped. So that's where we're headed next, configuring those particular devices and adding them to this safety circuit. So let's go ahead and complete the configuration of this safety circuit now. Okay, so we're going to go over to the left-hand side of our work area, and we're going to go select catalog. So these are all the basically devices that we've added to our system through that previous step. Okay, so what are going to be the devices that need to be on in order for our safe output to be active? Well, let's start with the door switch. Okay, that safety guard that we configured, address 10. Okay, let's go ahead and drag it to the AND gate. Okay, we've added that there. And then we've also got address 11, our e-stop. We want to make sure that that also is part of the equation. Okay, so those are the 2 devices that are going to need to be active in order for our safe output to also be active. But then we also have to configure some sort of a restart button. So what I'm going to do here is we're going to use the blue push button as our restart, the blue push button that's built into the tGard. Okay, and that happens to be connected to 12A, the first input for 12A. Okay, so the first input for 12A happens to be the blue push button. We're going to go ahead and drag that guy here, and now he shows up here. All right, so this is kind of the basic configuration we're going to use for this safe output. All right, Now, let's go ahead and go to our commissioning wizard. Okay, let's start that. Okay, it's prompting us to save our configuration for the work we just completed. Okay, now there's an ASi module reset wizard. That's the first step if you need it. That's for readdressing. We don't need to do any readdressing. We've already done our addressing. Okay. All right, next is I have to sign in here as the validator for the system. So I will do that. And then I need to create a password, which I will also do. Okay. Okay, and then we have to establish how we're going to communicate with the safety monitor. In this case, I'm going to be doing it over Ethernet. Okay, so I'll say OK here. I previously set up the Ethernet address. Okay. Should the interface of the configuration in the workspace be stored? Yes or no? I'm going to say yes. Okay, now it's going through the process of preparing the master. And so we just kind of sit here and let that process complete. It's checking the nodes. Everything looks good. Okay. It's sending the configuration. The safety monitor is being restarted. Okay, that looks good. Let's hit finish. It's prompting us to save again. We'll do that. All right, now we're online. And basically, it looks like we have our door switch in the proper position. We've got our e-stop button in the proper position, but we need to basically restart to get our safe output active. So we configured the blue push button to do that. So I'm going to press the blue push button now. And there we go. As you can see, our safe output is now active. So we've completed this part of the configuration. All right, let's take a look at the final demo we have here on the bench now that everything is configured and I've got a program running in the OCS controller. Okay, so what we're doing here in our demonstration is we're mimicking what we've got here going on with our tGard, okay, with our blue and yellow lighted push buttons, our e-stop button, and our two key switches. All right, so currently our safety circuit is waiting to be restarted. Once again, we're using the blue push button to restart the safety circuit. Once that's pressed, then everything is good here. All right. Now, I've used this general purpose push button here, this yellow one, as a dual purpose start-stop button for my motor. So I can start and stop from the touchscreen, or I can start and stop from this button here. When the motor's running, this becomes a stop switch. When the motor stopped, this becomes a start switch. That's just how I chose to program this. These are completely flexible general purpose buttons you can do with as you please. Okay, let's go ahead and trip the e-stop here. As you can see, our safety output turned off. When I return this to the normal position, you can see now we're ready to be restarted. Once again, the blue push button takes care of that. All right, if I change my door switch now, you'll see again, my safety output turns off. And if I want to actually open up the door, I then have to move this switch here, and then my door is free to open. Okay, and then I can, again, close the door, move the switch. You'll notice my switch updates on the screen as well, my switch position. I'm using the enhanced properties in those graphic objects to take care of that. And then when I move this guy back to the proper position, we're ready to be restarted, and away we go. Okay, so that's the bench demo that I've created here where we're mimicking the tGard on the screen. Now let's take a look at our Cscape program that we use for today's demonstration. So one of the real key elements here is the communications between the OCS and the safety monitor, which of course is driving the tGard over ASi. All right, so for that we go to LAN 1 because that communication is done over Modbus TCP where the Horner OCS is the client. From a network configuration standpoint, it's all pretty standard. The only thing different than defaults is the timeouts, which have been reduced down to half a second. That is easily attainable with just 2 devices on the network. And we have taken advantage of master status and the ability to disable the network if we choose. Okay, so that's on the network level. On the device level, we just have the one device here. This is the network monitor. That's the IP address for the network monitor. It uses Modicon 5-digit addressing. It also has status available to it. And then on the final level, we have our scan list. And this is the scan list that's required for this application. The first 16 words of read-only polling data is coming in from the safety monitor, and that is the ASi inputs, okay, the ASi input data. And then we have 16 words of ASi output data as well that we've set up for read-write. Now, this particular gateway, the Bill Wiedemann, does not support writing 1 word at a time. So to ensure that we're writing at least 2 words at a time, we've handled our 16 words of ASi output data as 8 double words. So again, that guarantees we always write at least 2 words at a time. And then we have our final, basically our final word of data that we're reading from the safety gateway, which is the status of the safety circuits, or at least the first 2 safety circuits. In our demonstration today, we're only monitoring the first 1. Okay, so that's the Modbus configuration, Modbus TCP configuration for our system. In terms of the logic, we have an ASi section here of our logic where we're basically taking data that we're receiving in over Modbus TCP, which represents the status of the ASi inputs, creating internal variables then that we use throughout our program. And then, we've got that for several inputs, the status of the e-stop circuits, the status of the push buttons and key switches, that sort of thing. We generate a Modbus OK indicator so that we know when things are going well and when they're not, so we can react accordingly. We have the status of our safety circuit that we're monitoring here, okay, again, over Modbus and creating some states for that safety circuit. And then we've got some output control as well for our, basically for our blue LED and our yellow LED that we're controlling over ASi. So that's the ASi section of our code here. You can look at this in as much detail as you like if you download it from our website. We've also got, let's take a quick look at the screen that I showed you from the bench. All right, so here's our main ASi screen. So this is all standard operators, standard devices for the Canvas series of graphics. These key switches are fairly nifty. Those are available under clip art, okay? And we're actually controlling the advanced attributes for these particular devices so that we can control the angle they're displayed at to indicate in real time, the physical position of the key switch. So that is done through the enhanced attributes. And then we have a little bit of logic here where we're effectively loading in the angle that we want those key switches to be displayed in depending on the status of the key switch, the feedback that we're getting over ASi. So that's really what we have here with both our logic and our screen work that we've done here in the Cscape demonstration. If you'd like more information from Fotress Safety, go ahead and contact them. You can check them out on their website at fotress-safety.com, or you can talk to your local Fotress distributor. Big thanks go out to John Pasqua again from Beal and Wiedemann, who's been providing me with plenty of equipment for these videos. If you would like more information on ASi safety or ASi in general, you can contact John at the number on the screen. That does it for our topic for today. If you're interested in attending training next year, we have 2 courses scheduled for the first quarter, a basic course in February and an advanced course in March. Get to our website and sign up today. We are all done with trade shows in the United States for 2025. However, the biggest trade show in the world, at least as far as I'm concerned, is happening in Nuremberg, Germany, and I'll be attending, and maybe you should too. The Horner Europe team will be displaying all the latest Horner products, and of course, because it's such a huge show, there'll be lots to see in Nuremberg. So I'll be joining the Horner team in Europe. Maybe you should too. Okay, if you'd like to interact with Horner Automation online, you can do so on our website at hornerautomation.com, on our YouTube channel where we have hundreds of YouTube videos like this one, and on LinkedIn. Next week, we're going to be covering in some detail, actually quite a bit of detail, how to use Control Techniques drives with Horner controllers. Now, we've covered briefly CT drives. I believe it was with a topic we did on troubleshooting RTU Modbus networks. But we're going to be dedicating the entire process, or the entire live stream, I should say, to the CT drive. So after that's over with, you'll have all the tips and tricks on how to interface those with Horner controllers. Now, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week when we talk Control Techniques drives, let's get out there and do some good.